Good afternoon, class. We are looking at trigonometric functions. Section 3, properties of trigonometric functions. So we looked at angles and their measures, trigonometric functions, unit circle, and now properties of trig functions. So the objectives are find the domain, range, and period of trigonometric function, determine the sign of the trigonometric function in a quadrant, find the value of the trigonometric function using I, fundamental identities. Find the exact values of the trigonometric functions of an angle given one of the functions and the quadrant of the angle. Finally, use even odd properties to find exact values of the trig functions. So a quick reminder, this is a line, goes indefinitely on both sides with a zero thickness. So we have the vertex, the initial side, the terminal side creates in a counterclockwise, creates a positive angle. Clockwise, it creates a negative angle. If the initial side is along the positive side of the x-axis, it's in standard position. This one is positive, this one is negative, both of them in standard position. Quadrantal angle, any angle where the terminal side is along the x or y axis, positive or negative. A complete revolution is 360 degrees or 2 pi radians. 1/4 of a revolution is 90 degrees or a right angle. Straight angle is half of the revolution. Initial side, terminal side, initial along the positive and terminal along the negative side of the x-axis. The relationship between degrees and radians, d over 180 is r over pi, because pi radians is 180 degrees. 1 degree is 60 minutes, 1 minute is 60 seconds. This is the arc length S equals r theta, and that is the area known as half the a sector, a portion of the area of a circle. Area is 1/2 r squared theta. Angular speed, omega is theta over t, or 2 pi times rpm, revolutions per minute, revolutions per second, and so forth. Linear speed is s over t, which becomes r omega. So that's the synopsis of what we had seen before. Also, if you look at this concept, the unit circle, okay, a circle has a radius at 0, 0, the formula is x squared plus y squared equals r squared. If the radius is 1, we call it a unit circle. In the case of a unit circle, x squared plus y squared equals 1. Any point P having coordinates x comma y, x is cosine, y is sine, and the reason is because the hypotenuse is the radius, which is equal to 1. And so tangent is y over x, or sine over cosine. Cotangent is x over y, the reciprocal of tangent. So cotangent, cosecant, and secant are reciprocal. So basically, cotangent is cosine over sine, or 1 over tangent. Cosecant is 1 over y, or 1 over sine. Secant is 1 over x, or 1 over cosine. However, if from the unit circle x squared plus y squared equals 1, we go to a general case of x squared plus y squared equals r squared. Now, P with coordinates x comma y, we're going to call a comma b. Sine is y over r, because r, in the case of a unit circle, was 1, but it's no longer 1. Or b over r. Cosine is x over r. As long as we have these two, we can figure out the rest. Tan is y over x. Cotangent, cosecant, and secant are the reciprocal of those. As far as the exact values of a trigonometric functions, we discussed when theta is pi over 6 or 30 degrees, pi over 4 or 45 degrees, pi over 3 or 60 degrees. These are trigonometric values we should know. Just for the sake of argument, pi over 6 is the same as 30 degrees, and sine is 1/2. Cosine is square root of 3 over 2, and you can figure out the rest. For example, tangent is sine over cosine, and these 3 are the reciprocal of these 3. So it's really not too bad to know. Quadrantal angles, just remember the coordinates. For example, the coordinates 1, 0. Okay, that can help us see what's happening. Cosine of 0 is 1. Sine of 0 is 0. Now, properties of trigonometric functions, domain and range of trigonometric functions. So sine and cosine are real numbers when it comes to the domain. Tangent are real numbers except odd integer multiples of power 2. Cosecant except integer multiples of pi. Secant almost the same as tangent except odd integer multiples of power 2, and cotangent all except integers multiples of pi equals 1 over 80 degrees. And one way to understand that, all you have to do, write down tangent is sine over cosine. So cosine can't be 0. Cosecant is 1 over sine. Secant is 1 over cosine. Cotangent is cosine over sine. So the denominators can't be 0. And you can see that as a result of that. So for sine, the domain is negative to positive infinity. Cosine, the same thing. Tangent is minus this, and so on. The range, for sine, the range is negative 1 to 1. For cosine, is also negative 1 to 1. Cosecant is less than or equal to negative 1 or larger than or equal to 1. In other words, anywhere, anything between negative 1 and 1 is not covered. The same thing goes for secant. Anything between negative 1 and 1 is not covered. But tangent and cotangent, they have no restriction when it comes to the range or real numbers. So you can look at this, you can look at what I wrote here. And when we look at the graphs, it becomes easier to remember all of the above. So that's a synopsis of what we need. Let's continue on that thoughts. Determine the period of a trigonometric function. A function f is called periodic if there is a positive number p such that whenever theta is in the domain of f, so is theta plus p, and f of theta plus p is f of theta. If there is a smallest such number p, this smallest value is called the fundamental period of f. So for example, you can see this is theta. So if we can go a complete revolution and come back to the same terminal side, that's theta plus 2 pi, and you can keep on doing that. So, for example, sine of theta plus 2 pi k is sine theta, cosine of theta plus 2 pi k is cosine theta, where k is any integer. And of course, by integer, we mean 0, 1, 2, 3, negative 1, negative 2, negative 3. So k is an integer. So with that being the case, if we go a complete revolution, we end up with the same spot. So that works for sine, cosine, secant, cosecant. However, it so happened in the case of a tangent, remember this is A, this is B. So right here is minus A minus B. So B over A and minus B over A are the same. So it happened to be that in the third quadrant, tangent has the same value as the first quadrant. Therefore, for tangent, the period is simply pi, which cotangent follows in the same manner. So sine, cosine, secant, cosecant, all of them, theta plus 2 pi gives you the same result. But in the case of a tangent, it's just pi, and therefore cotangent follows in the same manner. So for sine, cosine, secant, cosecant, you have a complete revolution or multiples of that. But for tangent and cotangent, any multiple of pi will do. Okay. So we want to find the exact value using periodic property, sine of 17 pi over 4. All you have to do, follow that and take out a complete revolution or multiples of that. You may recognize this as pi over 4 plus 16 pi over 4, which is 4 pi. So that means we've gone around this 2 times, a complete revolution 2 times. 4 pi is 2 times 2 pi. And therefore, it gives us sine of pi over 4, and we should know sine of pi over 4 is square root of 2 over 2. Cosine of 5 pi. So we go a complete revolution if we go with 2 pi. So basically, this is going around twice, so pi plus 4 pi. So once, 2 times, and then we do the pi. So that's the same as cosine of pi, which is -1. So take out multiples of 2 pi, or even multiples of pi. Cosine of 5 pi over 4. It's simply in the third quadrant. That is tangent, my apologies. And we said for the case of tangent and cotangent, it's just pi. That is the period. So it's the same as tan of pi over 4, and we know tan of pi over 4 to be 1. So information using periodic properties can easily give us the answer. Determine the sign of the trig functions in a quadrant. So this is quadrant 1. X and Y are positive. This is quadrant 2. X is negative, but Y remains positive. This is quadrant 3, and both of them are negative. And so we know X represents cosine, Y represents sine. So if we look at this piece that is given, X is, of course, this is the fourth quadrant, where X is positive, that means cosine is positive. Y is negative, that means sine is negative in the fourth quadrant. So to remember this concept, just remember X and Y. So what about tangent? Since tangent is Y over X and one of them is negative, doesn't matter which one, it becomes negative. And the rest of them are reciprocals. If sine is negative, its reciprocal 1 over Y or cosecant is negative. If cosine is positive, its reciprocal secant or 1 over X is positive. And if tangent is negative, cotangent X over Y is also negative. So if we look at this, over here it mentions all positive. In this case, sine, and therefore cosecant is positive. In this case, tangent, and therefore cotangent is positive. In this case, say quadrant 1, 2, 3. Quadrant 4, cosine is positive, so is secant. Over here at the top, sine is positive, so is cosecant. To the right, cosine is positive or secant, both cases. And tangent and cotangent are positive here. In any event, we should have no problem remembering this by looking at x and y. And this actually gives you the synopsis of that. In the first quadrant, again, remember you're dealing with the unit circle. So this is cosine, this is sine. Everything is positive, everything. In the second quadrant, sine is positive. If sine is positive, so is cosecant. In the third one, tangent is positive, so is cotangent. In the fourth one, cosine is positive, so is secant. So look at this one. I think it's easy to remember that. All right. Finding the quadrant in which an angle lies, given the information, if sine is positive and cosine is negative. So sine theta is positive, cosine is negative. Name the quadrant in which the angle lies. And of course, this should really pretty much tells you the idea. So although this will give you the answer, it will give away the answer. Let's look at the first one. If sine theta is positive, that means y must be positive. And that means the angle must be in the first or second quadrant. Over here, sine is positive. Cosine is negative, that means x is negative. If x is negative, then the angle must be in the second or third quadrant, this vicinity. And as you can see, what's in common? Quadrant 2. So the answer is quadrant 2. So again, this is in common. Makes the answer quadrant 2. In quadrant 2, sine is positive, cosine is negative. And you can even see that sine is positive, cosine is negative. Pretty straightforward, everybody. Fundamental identities, we know x squared plus y squared equals 1, and P has coordinates x comma y, cosine theta, sine theta. If x squared plus y squared is 1, then cosine squared plus sine squared or sine squared plus cosine squared must be 1. Very simple. That's one of the Pythagorean identities. Now, let's divide both sides by cosine squared. So we divide everything by cosine squared. What is this? Tan squared. What is this? 1. What is this? 1 over cosine is secant. 1 over cosine squared is secant squared. So this is another Pythagorean identity. When sine squared plus cosine squared is 1, that can be used to prove tan squared plus 1 must be secant squared. Now this time, let's go back to this one and divide both sides by sine squared. Let's divide both sides by sine squared. So what happens? This is 1. Cosine over sine is cotangent. Cotangent squared. 1 over sine is cosecant. Cosecant squared. That means 1 plus cotangent squared is cosecant squared. That is also Pythagorean identity. So here's the fundamental identities, everybody. Pythagorean identity, sine squared plus cosine squared equals 1. Tan squared plus 1 is secant squared. 1 plus cotangent squared or cotangent squared plus 1 is cosecant squared. Quotient identities, tangent is sine over cosine, cotangent is cosine over sine. Reciprocal identities, cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. So this is a bunch of identities that are going to be used here. I hope everybody is comfortable with. All right, find the values of the trigonometric functions using fundamental identities. Find the exact value of all trig functions where sine is square root of 10 over 10, cosine is 3 square root of 10 over 10. Well, if sine is square root of 10 over 10, cosecant is the reciprocal of that. Tangent is sine over cosine. So divide the sine by cosine, you can see that the denominators are identical. You drop them. Just put it at top. So you have square root of 10 over 3 square root of 10. And this, if you drop the square root of 10, you get 1/10. The rest of them are the reciprocal. So we have sine and cosine. We find tangent, the reciprocal of this, the reciprocal of this, and the reciprocal of this are the rest. That's all there is to it. So this one, the reciprocal 10 over square root of 10, or simply 10 over square root of 10 equals square root of 10. So that's the formula. Reciprocal of that, 10 over square root of 10 is square root of 10. Secant is 1 over cosine. The reciprocal of that 10 comes at top. And I hope you know that, first of all, there are two ways to handle it. If you divide 10 by square root of 10, you get square root of 10. Or if you multiply, so let me show you the second method, and I'm going to erase it afterwards. If you have 10 over 3 square root of 10, and you want to rationalize it, if you multiply the top and the bottom by square root of 10, what happens is that you get 3, and I'm not going to write 30, 3 times 10, and then 10 square root of 10. These two cancel each other, and that's how you arrive at it. But it's really good to know. For example, 5 over square root of 5 is square root of 5. You should know that at this level. I'm going to erase the work. So now if tangent is 1/3, cotangent is 1 over tangent, and it must be 1 over 1/3 or 3 over 1 or 3. So it's the reciprocal. So it's pretty straightforward, everybody. So fundamental identities, and we will have more identities coming your way. So you want to get very comfortable with those identities. All right, find the exact value of each expression, and we're not going to use a calculator. So 1 over cosecant squared 35 plus cosecant plus cosine squared 35. So how do we handle this? First and foremost, 1 over cosecant is sine. Remember, cosecant is 1 over sine. So sine is 1 over cosecant. So this is sine squared. And sine squared plus cosine squared is 1. Sine squared of any angle or arc, 35 degrees plus cosine squared of 35 degrees must be 1. Cosine over sine is cotangent of the same angle. Both of them are the same angle. So this is cotangent. So cotangent of power 3 minus cotangent of power 3 must be 0. They cancel each other. Tan of 20 degrees minus sine of 20 over cosine of 20. Well, sine over cosine is tangent. So we replace this with tan of 20 degrees. They cancel each other. The answer is 0. Sine squared of pi over 12 plus 1 over secant squared of pi over 12. So we know that secant is 1 over cosine. So cosine is 1 over secant, and 1 over secant squared is cosine squared. So this, again, look at this one. If 1 over cosine is secant, then 1 over secant must be cosine. So this is cosine squared. Sine squared plus cosine squared must be 1. So knowing the identities truly helps. Find the exact value of the trig functions of an angle given one of the functions and the quadrant of the angle. A couple of methods. Method 1, use circle. So what do? Here's a circle, and a point has coordinates x comma y, and understand theta, theta plus 2 pi, and so forth. Draw a circle. Circle of radius r centered at 0, 0, x squared plus y squared equals r squared. P has coordinates x comma y, and r is square root of x squared plus y squared. So we know that. Now, number 2. Assign a value to 2 of the 3 variables. We have x, y, r, based on the value of a trigonometric function. Calculate the missing variable, and you want to pay attention with the quadrant, for example, which one is positive or negative. Use the formula to find the rest, meaning these are the formulas. X squared plus y squared equals r squared. P has coordinates x comma y or a over b. Sine, as an example, is y over r or b over r. Cosine is a over r, and the rest of them follow in the same manner. The second method is to use identities. And we already discussed fundamental identities such as sine squared plus cosine squared equals 1, tan squared plus 1 equals secant squared, tan theta is sine over cosine, and so on. So it's important to know the identities as well as the methodology using the circle. So, for example, number 5, find the exact value of all trig functions where sine is 2 over 5, cosine is negative, and we are going to use both methods for the sake of practice. You don't have to do both methods, you have to know both methods. So we're going to use the circles. So first, here's the formulas that we discussed. These are the formulas we're going to use. Secondly, sine is positive in the first and the second quadrant. We know that 2 over 5 is a positive value. So it's either in the first or in the second quadrant. Cosine is negative in the second or third quadrant, so it must be the second quadrant. So that's the first thing to figure out. I hope everybody is clear. So it belongs to the second quadrant. Sine is y over r or 2 over 5. That means we have the r. R is always positive, remember that. Y is also positive too, and x is missing in action. So we have a coordinate P, we have a point with coordinates x, which is missing, and 2, and we know x to be negative. So x squared plus y squared equals r squared. That means x squared plus y squared is 4, r squared is 25. So subtract from 25, you get 21. X is either positive or negative 21. We already know it belongs to the second quadrant. It must be negative. So now that we have the x value and y value and r value, just plug it in. So we have the sign. Cosine is x over r minus square root of 21 over 5. Tan theta y over x. I mean, you can mix and match. You can even use the formulas. Tangent is sine over cosine. Either way, y over x 2 over negative square root of 21. I have a feeling nobody has any problem rationalizing these numbers. Okay, so I'm going to assume everybody can do that, but just quickly, the idea is to multiply this one by 21 or square root of 21 over square root of 21, and you get this. Now, cosecant is r over y, so 2/5 becomes 5/2. Secant is r over x, 5 over negative square root of 21. And again, if you want to rationalize it, you can. And cotangent is x over y, x minus square root of 21 over y, which is 2. So you can go this route. It's very straightforward. It shouldn't be any problem, everybody. Or we can use identities. These are the fundamental identities. Sine is given. And since cosine is negative, and we've already established y, it's in the second quadrant. Because sine is positive, cosine is negative. We use sine squared plus cosine squared equals 1. Replace the sine with 2 over 5, so 2 over 5 squared. Four over 25, subtracted from the right side. 21 over 25, so cosine is plus minus the square root of 21 over 25. The 25 comes out as 5, and cosine is negative, so choose the negative one. That's because of the quadrant, and besides, they said so. Now that you have sine and cosine, practically you're done. Tangent is sine over cosine. 2 over 5 and negative square root of 21 over 5. This becomes negative 2 over square root of 21 and then rationalize. So you have all those three now. The reciprocals are cotangent, cosecant, secant. So first you go with the reciprocal of this one is sitting right there. So cotangent is the reciprocal of this one, or the reciprocal of this one, if you want it. Well, that's actually easier to go with that. The reciprocal of this one. Okay. Minus square root of 21 over 2. Cosecant is 1 over sine, the reciprocal of sine, so 5/2. Cosecant is 1 over sine. Secant is the reciprocal of cosine. Minus 5 over square root of 21, and you rationalize it. I'm going to assume everybody knows how to rationalize. Again, it's square root of 21 over square root of 21, resulting in this. And notice sine is positive, so is cosecant. Everything else must be negative, and they are. So, a quick recap. We did this by the method of cell cones. X squared plus y squared equals r squared. The denominator is r, the numerator is y. They were given, and we found x. And we decided x is negative because of the quadrant. And we used, for example, sine is y over r, cosine is x over r, and so on. The second method, we use identities. We have fundamental identities such as Pythagorean identities. Quotient identities, reciprocal identities. So because sine is given, sine squared and cosine squared, they add up to 1. We can find cosine. As long as we have 2 of them, we can easily find the rest of it. So that's using identities. All right, we want to find the exact value. Again, for practice, we are going to do both methods, where cotangent is 1/3 and sine is negative. Now, if cotangent is positive, that means it's in the first. This means either the first or the third quadrant. But sine is negative, and that's in the third or the fourth. What's in common? It's the third quadrant. Okay, everybody? So we know y is in the third quadrant. And in the third quadrant, both x and y must be negative. So cotangent, which is x over y, and it's equal to 1/3, is the same as negative 1 over negative 3. Both of them are negative. And we put it into x squared plus y squared equals r squared to find r. 1 plus 9, it's 10, r is square root of 10. And so practically we are done because we found everything that we wanted. So sine is y over r. Cosine is x over r. Tan is y over x. And so you can start with one of them. Since we have x and y, let's go with tangent first. Tangent is y over x. In other words, the reciprocal of that, 3. Sine is y negative 3 over r. Now, negative 3 over square root of 10, I'm again assuming everybody knows. Again, I'm going to write this for you, but by now everybody knows that you have to multiply this by square root of 10 over square root of 10 to have it rationalized. Everybody knows how to do that. And so that sine theta, cosine is x, negative 1 over r or square root of 10. But maybe we go with the reciprocal of that. Sine is this number, minus 3 over square root of 10. Cosecant is 10 over square root of 10 over minus 3. So cosecant is r over y. Cosine is x over r, negative 1 over square root of 10, and rationalized. Secant is the square root of 10 over minus 1, r over x. And square root of 10 over minus 1 means minus square root of 10. So we used circles, and in any order, as long as we get x, y, r.
I'm thinking of doing it chocolate now.
We're going to continue with the same question using identities. Cotangent is 1/3, sine theta is less than 0. So we use one of those identities. And again, we've already established that it's in the third quadrant and why. I'm not going to go over that again. We use this identity 1 plus cotangent squared is cosecant squared. So 1 plus 1/3 squared equals cosecant squared. Now this is 1 over 9. 1 is 9 over 9. They add up to 10 over 9. So cosecant is the square root of this plus minus square root of 10 over 9. 9 comes out as 3. And then if sine is negative, so is cosecant, or just this is quadrant 3. Everything is negative except tangent and cotangent. So cosecant is negative. So you choose, there are two of them, you choose the negative one. So since we have the cosecant, well, the sine is the reciprocal of that. So sine is 1 over cosecant. So the reciprocal of that is minus 3 over square root of 10. And rationalization results in minus 3 square root of 10 over 10. And since we have cotangent, tangent is the reciprocal of that. So 3 over 1 or simply 3. Now, at this point, we can use many different methods to get to cosine, everybody. I want you to know that. For example, you can use sine squared plus cosine squared equals 1. But the fastest and easier way is to notice if tangent is sine over cosine, and again, this is the fastest way. It's not the only way. It's the best way. If tangent is sine over cosine, that means cosine is sine over tangent. Please, I hope you understand this. It's just or you can do the cross product to see that. You can interchange these two. If cosine is sine over tangent, let's plug in. We have the sine. We have the tangent. And it's minus square root of 10 over 10. When you have cosine, then secant is the reciprocal of this number. Okay, and it's negative square root of 10. So very straightforward, everybody. So again, a quick recap. Cotangent is 1/3, and that is x over y. So x can be 1, y can be 3, or both of them negative, because we come up with the third quadrant. That means both of them are negative. We can calculate the r, and we go with the circles. Or having cotangent, using the Pythagorean identity, cotangent squared plus 1 equals cosecant squared, you can find one more, in this case cosecant. And then as long as you have two of them, you can find the rest of them easily. All right, here's example 7, even and odd functions. As you recall, an even function f of minus x equals f of x. An odd function f of minus x is minus f of x. Therefore, we want to use even and odd properties to find the exact values of the trigonometric functions. Well, in the first quadrant, P has coordinates x comma y. Then if you go with negative theta, everybody, so theta is positive, counterclockwise, this is negative clockwise, and x remains, but y becomes negative. So in the fourth quadrant, x doesn't change, but y changes. And right away, we recognize this, that in essence, because x represents cosine, cosine doesn't change. And with cosine goes secant. But everything else, every trigonometric function is an odd function except cosine, and therefore secant. So we write sine of negative theta is minus sine theta. With that, cosecant minus theta is negative cosecant theta. Tan of minus theta is minus tan theta. Cotangent of minus theta is minus cotangent theta. However, cosine, because it's represented by x, and the first and fourth quadrant, they are both positive, cosine of minus theta doesn't change, remains positive, and secant is 1 over cosine, the same thing. So those are the only two that are positive. So having said that, cosine of negative 60 is the same as cosine of 60. That's a common arc. It's equal to 1/2. Sine of negative 390 degrees, negative comes out because it's an odd function. Now, 390 degrees, we know that it's 30 plus 360, and 360 is a complete revolution. So it's the same as minus sine of 30 degrees, and that is minus 1/2. Tan of negative 37 pi over 4, we take the negative out because tangent is an odd function. So minus tan of 37 pi over 4. In other words, if you have a negative as the argument, make sure you get rid of it using the property that works for it. So if this is the case, 37 pi over 4, we should recognize a number that is larger than 2 pi. And because 36 pi over 4 is like 9 pi, and remember, in the case of a tangent, we want multiples of pi, not 2 pi, because pi is the period for tangent and cotangent. So 36 over 4 is 9, so 9 pi. So that doesn't have any bearing. So it's the same as tan of pi over 4, negative remains. Negative tan of pi over 4. Tan of pi over 4 is 1, minus that is negative 1, and that's the final answer. Again, it's important to know, although this is 9 pi, it's not multiples of 2 pi. Because we are dealing with tangent, that works. So a quick recap. Definition of an even function, f of minus x equals f of x. Odd function, f of minus x equals minus f of x. And in the case of trigonometric functions, cosine is an even function, and therefore is secant. Every other trigonometric function is an odd function. So If cotangent theta is given as -2, we want to find cotangent theta plus cotangent of theta minus pi plus cotangent of theta minus 2 pi. And we know pi is the period of tangent and cotangent. So this one is also cotangent. This one is cotangent because this is multiples of pi. Doesn't matter negative or positive. And therefore you have 3 of those. And 3 times -2 becomes -6. So that's pretty straightforward, everybody. We want to find the exact value of sine of 1 degree, sine of 2 degrees, all the way to 359 degrees. So first, I want to start with 359. 359 is here or -1 degrees. 358 is here or -2 degrees. Negative 357 degrees is here or -3 degrees. So I hope everybody understands. So sine of 1, sine of 2, sine of 3, a bunch of signs in between. This one is sine of -1, this one is sine of -2, and so on. So what happens is that we know sine is an odd function. And therefore, sine of -3 is minus sine 3. This is minus sine 2 and so forth. So all those 3 become negative. So minus sine of 3 degrees, minus sine of 2 degrees, minus sine of 1 degree. And we're going to write a couple in between. So sine of 1, and this one is negative, sine of 1. We have sine of 2 and negative sine of 2. We have sine of 3 and negative sine of 3. And so what happens with the rest of them in the middle, this one cancels out this. Everything cancels out except sine of 180. So sine of 180 is the answer, but we know sine of 180 is 0. After 180 is 181, but remember, sine of 181 cancels out as well. All right. Let's look at, so sine of 180, which is 0. Now let's find the exact value for cosine. Cosine going from 1 to 359 degrees. Again, we are going to do the same thing. We keep those 3. This one is the same as -1, right? 359 degrees. Positive is the same as -1 degrees. So this is cosine of -1, cosine of -2, cosine of -3. However, cosine is an even function. Cosine is an even function. And what that means is that cosine of -1 degrees and 1 degrees are the same. So we're going to write it in this fashion. So what do we have? We have two of those, 2 cosine 1. We have two of those. We have two of those. And we're going to continue with the rest of them. So we write as follows. We have 2 cosine of 1 degrees. We have 2 cosine of 2 degrees. And we continue 2 cosine of 178 degrees, 2 cosine of 179 degrees, and cosine of 180 degrees, we have only one of them. So we write the first three as an example, cosine of 1 degrees, and we're going to write this as 180 minus 1. We're going to write this as 180 minus 2. And the one before that, 180 minus 3. So let's write them. So we have 2 cosine 1, 2 cosine 2, 2 cosine 3. Corresponding to cosine of 180, there is nothing. Corresponding to cosine of 179, we write 180 minus 1 is the same thing. For the next one is 180 minus 2. For the next one, which is missing, is 180 minus 3. And what's important to know? The first quadrant, cosine is positive. The second quadrant, and they are all in the second quadrant, cosine is negative. In other words, this one, cosine of 1 and cosine of 180 minus 1, they have the same value, but one is positive. That means cosine of 1 is positive. Cosine of 179 or 180 minus 1 is negative. They cancel each other. This one cancels out this one, and this cancels out this one. The final answer is cosine of 180. Cosine of 180, we should know it's equal to negative 1. So that's the answer. From a parking lot, you want to walk to a house on the ocean. So here's the parking lot, and here's the house, here's the pathway, and here's the sand. The house is located 1,500 feet down a paved path parallel to the ocean. So this is the paved path, which is 500 feet wide or away. So the distance of 500 feet here. Along the path, you can walk 300 feet per minute, but in the sand, on the beach, you can only walk 100 feet per minute. That means obviously slower. See the illustration. The time t to get from parking lot to the beach house can be expressed as a function of the angle theta, this angle. In other words, you walk along the pathway. At some point, you are going to walk in the sand. If you go here, this angle is 90 degrees. If you go here, depends on where you pick to go through the sand, the angle changes. So the angle represents the angle that you make with the house. And so as you walk on the sand. So calculate the time t if you walk directly from the parking lot to the house. I'm going to do this two ways. First, I'm going to look at this. It says t of theta is 5 minus 5 over 3 sine 3 tangent theta plus 5 sine theta, where theta is between 0 and pi over 2. In other words, you can choose to go directly here or go all the way down and up. That's the idea as far as the theta. You can take any moment you want to walk on the sand, because at some point you must. And they have found a formula to be this one. So By the way, tan of theta 0, it could be going here and here. Okay, you can go straight here and that way. Okay, that's another one. This is theta. Or you can go this way and up. If you go here, it's 90 degrees. If you go this way, it's 0 degrees. And then all the way to here. So this you choose 0 degrees to begin with. But can't be 0, can't be power 2. Let's just look at what happens here. So this is 500 feet. This is 1,000 feet. And the theta is here. So I'm going to use both methods. Going with the fact that this is 3 times this one. So let's go with easy numbers. Okay. So tan is 5. Tan theta is the opposite 500 over the adjacent 1500, 1/3. So we're going to say y over x. And so y becomes 1. X becomes 3. And since r squared is x squared plus y squared, 9 and 1 is 10, r is square root of 10. So we are going to say this acts like an x equals 3, this acts like a y equals 1, and this acts like a r equals square root of 10. So if we want to go with the methodology of this section, we know sine is y over r, so 1 over square root of 10. So 5 minus 5 over 3 times tan of theta. Tan of theta is 1/3 plus 5 over sine theta, 1 over square root of 10. So that would be the answer. You can put that into a calculator. You can simplify it. This is still 5. Okay. This is 1, so minus 5. And this one becomes, I hope you recognize this comes up, 5 square root of 10. So it's precise, these two cancel each other. So it's precisely 5 square root of 10 or 15.8 units of time, minutes. However, this is using the trigonometric version that we learned in this section. However, this can be done in the following manner. Because we are looking at going from this point to this point, we can calculate. So directly from here to here, we can calculate this distance of r and then divide by the speed, which is 100 feet per minute. So r squared in this case is x squared plus y squared, but we are talking about the original one. Originally, this is 500. This is 1500. Square this one, square this one. Then you take the square root and you get 1581.14. Divide by the speed by which you can walk on the sand, 100 feet per minute. Divide by 100, and you get exactly the same answer. Now, one might say, okay, if this is easier, why did we go this route? The idea is, what if we don't go directly from this point to this point, but rather we go along the pathway for a while, and then we use the sand. That's why they have this formula here.